should have discussed this already, because this is quite important if you work on a command line. But I think it's never too late to speak about it. And I will speak about today how programs output things. How can you catch the output? How can you catch different types of outputs of programs? And what can you do? What you can do with these things after you just code them. So the first thing I have to tell you is as soon as I'm logged into the server, right? So in the Unix or the Linux command line world, there are two different outputs. The first one is the standard output, and the second is the standard error. If you don't handle these outputs yourself, then both of them will go to your screen. So if you just let the program run and you don't care about the output, don't care about separating these two things, then they will be mixed together and they will be put on your screen. In many cases, this is okay because you just want to see, for example, a percentage. If you just run quickly a script and you want to see what's the, like a blast, and you want to see what are those contigs or what are those AMR genes you find in your assembly. And if you do this for just one sample, then it's okay just to have this on your screen. So I think the best example is for example, if you run abricate. So if you go to, if I'm going to my folder now, but it is also true for almost all of these programs we already discussed. All of them are putting something on your screen. So if I just run the abricate on one of my context.fasta, then what you see here are the mix of different lines, and it will finish soon. So for example, what you see here, this is some kind of message that is about the running of the program. Okay, so this is saying that abricate is now running using the NCBI database, which has this many sequences and was updated that time. The next line is actually is a result. So it's not about the parameters of the program, how it runs, but it is the result you want to see as your, which is, answering your question, what are the antimicrobial resistance genes I have there. The next line is again a kind of message from the program that I am now processing this file. And then there is a short message about finding 14 genes, and then a list again. And these are much more results. And then there is a tip, there is a tip at the end, which is just coming from Thorstein. This is his style. Usually have some kind of joke or funny tip at the end. Sometimes it's not funny, sometimes it's a good thing. And then a done, which is again just a message from the program. So in reality, we are seeing here two different things mixed together. Abricate is outputting things to the standard output and outputting things to the standard error as well. If you want to catch any of them, you can do it, and you can do it in a different way. So you already saw something from me before, something like this, when you use the pipe and you directly put the output, the standard output, or give the standard output to a new program and give it that program standard input. And you also saw this one before, when you don't pass the standard output through, but you are actually writing it into a file. The most simple way to demonstrate the difference here is by using this. So what I'm doing now, I am using this sign to put everything into a file, which you see here, or maybe not everything. That's what will turn out very soon. I will just call it as a temporary out.txt. Okay. So what I want to do, I want to put the things from here into this file, which will be in my, I hope there is nothing like this. And there is nothing like this here. So I won't overwrite anything. And if I run this, interestingly, I have a few lines on my screen as well. So why are these here? You know, it's the same few lines that we saw here, and another few lines we don't see anymore. And if I'm looking into the file I created, I only have the real results there. And this is the main difference between reporting or printing to standard output or the standard error. So what happened here is that when I'm running Abricate, Abricate will put a few lines, a few outputs into the standard output, another few in the standard error. With this sign here, with this more than or less than sign, I'm only redirecting the standard output. In Perl, it is, and I think actually Thorstein is using Perl programming language, so probably the Abricate is also written in Perl. In Perl programming languages, it's very, very, very simple. Let me just show you, yeah, like something like this. This is not the best one. I want to show you. You don't have to look all the scripting because it's not that important here. I just want to show you something. How easy is to, yeah, okay. So look at this line here. I tell the program to print something to the standard error, and this will, this will be printed to the standard error, of course, without the semicolon. That's just ending the line. In the same script, I have something like this here, down, a very long line, printing out a lot of things, but there is no stderr like here or there, which means that this will be printed to the standard output. So it's like two different packets you can handle differently. Let's go back here. So in general, we can say that in many programs, if the program is not creating a real output file in default, but the program is outputting the results to the screen, then usually the real output you want to see as a result from a program is almost always going to the standard output, and anything else, which is much more like the status of the running, is going to the standard error. So if you do this with one file, then it's okay because you saved actually your results, which is in your txt file, and you can also see in the meantime just on your screen that okay, the program worked from the very up-to-date NCBI database, and I should look into the output file because there are 14 genes there that were found. If you see found 0 genes here, then there is no point to look into the txt file. Okay, so, and this was only running for a few seconds, but of course many times you are running things for hours, not just Abricate. You can run Proca for hours, you can run Space for hours. If you think about our metagenomics sequencing, the Space is running usually for more than a day, just one run, which means that you will not sit in front of your screen and look at the output and check, okay, I see that this sample, I found that many genes, and I found those genes, and I see some error. So if you would like to follow what is happening, usually what you do is something what we discussed a few meetings ago. So if you have a lot of samples, you just simply put this end sign at the end, and then log out and go to sleep. And maybe next morning you are just checking that how your running is going. But if you do this, that means that everything that is going to your screen will be lost. So if I'm doing this, I will try to log out quickly. You know, if I'm doing this and then I log out, I saw the very first line of the standard error, which was processing something. And also I saw that it is using the NCBI database, but now I logged out from the server. I don't see the standard error anymore. I don't see if there is 14 or 0 genes. I don't see if there is any error happening during the run. So for that reason, if you want to do something like this, but you really want to save the standard error, then you have to do something else as well. In most of the cases, you don't need this because you don't expect any problem with runs. But as soon as you see something wrong and you have a suspicion that maybe something went wrong, then you can just simply go back, rerun. But this time, and I will now log back in, I logged back in and I don't see anything of those messages. You know, the program already finished running, but I don't see how many genes were found in context FOSTA because that standard error was just simply lost. So if I'm going back to my folder and run the same thing again, but this time I will do something else as well. I will do this. So of course, this file name is just my idea. So you can give any kind of file names, a bit more descriptive for your run, of course. So what I'm doing here is that with this part, I'm redirecting the standard output to the tmp-out.txt. With this part, I am redirecting the standard error to tmp_err.txt. So all the error messages will be saved. And if I want, I can put it in the background. I won't see anything because there is no more standard error going to my screen because everything is going into the file. It is done actually, so I didn't have time to log out. But if I'm logging out and I log back in, then I can just go back to this folder and open these two files. So if I'm looking into tmp out, it is of course the usual result table. If I'm looking into the tmp err.txt, then it is the standard error output, which is much more about the progress of your run. There is one more thing, it is especially useful if you really think that something goes wrong. There are many programs that are using a very limited amount of logging. So I mean that if you just run that program with default settings, then probably you won't see too much messages or too many messages on your screen. But if you think that maybe something is going wrong, you can almost always ask the program to report more. Let me just show you a few of these. I think Bowtie can do that as well. You know, we use Bowtie to align short next generation sequencing reads to whole genomes. And if you look at the Bowtie help, then I can imagine maybe the Bowtie doesn't have that kind of option to make it a bit more verbose. Okay. No, it doesn't have. Okay, I'm sure that the bowtie DB, bowtie to build, which we use to build up the bowtie database, it has a basic logging. Yeah. So for example, you can see here minus verbose, which means that it will be much more extensive what you see, but you can also say minus Q or minus quiet. This is not, this is a, this is an error in the help. If you say minus Q, that it will be very not verbose. So if you say minus Q, you won't see anything. So they just, I mean, I know because I usually use the minus Q option, which means that you see nothing as an output. So actually the minus verbose is this one. So they just mixed up the help, but actually if you use minus Q, then you won't see anything. If you don't use minus Q or don't use minus verbose, you will have a limited amount of output or like progress on your run. And if you use minus verbose, you will have much more. The same for Abricate. Abricate has this small amount of output, as you saw. But if you think that something maybe is going wrong, then you can use minus debug. So it's usually minus debug or minus verbose or minus V. You have to look for something like this. But you can also see here that there is a minus quiet option as well, which means that there is no standard error output. So if I'm running Abricate, remember when we ran Abricate just like this, everything went to the screen, the standard error and the standard output as well. If I'm saying minus quiet, then we will only see the results on your screen and not those extra lines about the database and how many genes were found. Okay, so again, this is happening in many programs. I'm sure that BLASTn has something like this. It has a version. It's usually where the not program specific options are. So yeah, it's the number of threads, for example, here. Of course, BLASTn will not have this option. Anyway, index input, or maybe it's in the output part. General search. Okay, let's just skip this. Maybe it doesn't have any options like this. But the most important thing, if you feel that something is going funny with your program, try to find the option which will give you much more about the progress of the program. And if it's going on your screen, then try to put it into a file. And the best way to put it, usually if it's a progress report, then it is going to the standard error. So use this thing here to redirect to a different file. There is a way to redirect the standard output and the standard error at the same time to the same file, but I think that's not as useful as this one. So you can even do this by just simply put the standard error somewhere else. So if you don't care about the standard error, but you want to save it just to be sure that maybe you will need it later on, then you can always do. That's okay. I will show this with a different file. So we have the Flash. I don't know if you remember the Flash program. If you look at the Flash, it was, I don't think we have it. Oh, we have it here. So we use the Flash to merge overlapping short read sequencing files. Okay, so this was the program. If you have the parent sequencing and your library size is not too far from your sequencing amount, I mean your insert size is not extremely big, that you have a chance that you are sequencing the same part of the DNA in the middle. And if you do this, then you can just merge the two pair ends sequencing to one single end sequencing. In default, Flash is creating output files. So this is another type of program. Instead of putting everything into the standard output, like Abricate or Blast or for example, SemTools. Yeah, the SemTools always put everything into the standard output. So Flash is in default creating files. So Flash won't put anything on the standard output. It will put your results into files, but it will create logs, and it's actually here. So there is many informational messages, which is in this case going to the standard output. Okay, so because Flash is not putting your results to the standard output, it can use the log messages. It can use the standard output for log messages, but this is maybe a bit confusing because in one case a program is putting your results to the standard output. In this case, it puts your log into the standard output. So that's why you always have to know what your program is doing. In this case, you just have to redirect the standard output. But interestingly, yeah, so this is what I mean, this is redirecting the standard error to the standard output. That's interesting. It's doing something very weird here. We can try actually to see what is happening, because Flash is not extremely long to run. Let's see. Yeah, we have a pair of FOSQ files here. So if I'm doing this, then it will run and give you these nice output. And also in the meantime, it is writing all the real results into those files. So this is what we have here. And again, if you run this and you are not really care about your combination percentage, then you don't really have to save this. But if you run something like this again in many hundreds of files and you want to go back and check the overlap rate of your sequences or your sequencing, then you may want to go back and check these files. So in that case, it's better to save them, because you probably run these in the background again, and you are not logged in and sit in front of your screen to see hundreds of merges. So let's first try with the redirecting the standard output, because it says that Flash is putting the log into the standard output. I will put it into the same file because we used before, the temp out.txt. So if I'm doing this, then you cannot see anything. Okay, so that's really going into the standard output. That's why I don't know why they use that very weird. Okay. So what you see here, there was only one thing here on your screen. So we started the run here. Everything went on the standard output except the warning. There was a warning, unexpectedly high proportion of combined pairs. overlapped, blah, blah, blah. It's not extremely important for us now. Probably this one went the standard error. So if you look into the tmp out txt, which catched, no, quote, the standard output, then you will see all these lines that were on our screen before. And if we run this thing by this, tmp underline error.txt, then the warning will go to the error.txt file. It is done now, and if we look at the tmp error.txt, it has the warning. Okay, so this is how you can catch the standard output and how you can catch the standard error. If you are not sure which one is used by the program, because maybe it's not written there in the help, then usually it's better just to try it on one sample. So if you are planning to run a program in multiple samples, then in the beginning, just try it on one, try to redirect the output first by this, and then by this. Again, if the program in default creates a result file, you don't have to worry about redirecting the result, because it will be in that file anyway. But you may be, you may want to redirect it, the standard error. That can be important. The next thing is if you want to use the standard output and give it to another program. Probably you saw me many times before using the WC, which is counting words, counting characters, or counting lines. So one of the easiest way to show, if you say ls, you are listing your folder. If you just want to see how many files you have in your folder, then you are using this pipe, and you are then using vc-l. What is happening here? ls, if you say ls, then it will put the list of your folder to the standard output. So this is now going to the standard output. If you do this, instead of putting the standard output to your screen, ls will give the standard output to a program, wc-l, which means that wc-l will take the standard output as its input and will count how many lines it has. The WC itself counts characters, words, and lines. If you just say WC-l, it will only count lines. And of course, ls is not, this is not 1, 2, 3, 4, 5, 6, 7, it's not 8 lines, what you see here. No, it's actually just 7 lines. It is 41 lines, but because we have small things right up under each other, it will just put them right next to each other. But in default, ls is putting one file name into one line. So I have 41 files in this folder, or 41 elements. So when you do this piping, it is called piped, or given to another program, you are only piping the standard output. So again, if I'm doing something like this, when we use the flash, I don't put the standard output and the standard error into a file. In this case, I'm just piping it to wc-l, wc-l, sorry. And what you will see is that the standard error will come to the screen and the standard output will be counted. Okay, the standard error is here, and we know that the standard output contained 108 lines. We can check this if we say wc-l just by itself, but we are giving a file name. And if you remember, we used the tmp out txt before to output the standard output of Flash. And it's really 108 lines. And this one, which was the standard error, it is just actually one line. I think it's much more one line, not four. Maybe it's four. Let's see in the error txt. Yeah, it's 4 lines. But for us, the most important thing here is that if you use pipe, it will only redirect the standard output, not the standard error. So if you continuously want to catch the standard error, then you have to do something like this. It was tmp error. So first you redirect the standard error to this file, and then you pipe the standard output and give it to wc-l. Okay, I won't run this, but believe me, it's working like that. Why do we have this standard output? Why many programs are using standard output? I mean, of course, if you have something like the ls, you say ls because you want to see your files in your folder. So I think it's obvious that ls has to give the results to you, which means that it has to put it on the standard output or the standard error, because it's showing up on your screen. But if you think about Abricate, why do you really want to put the results on your screen? Why there is no default output file like Abricate results.txt or something like this? There are two main reasons. While many programs are using, many bioinformatics software actually using the standard output as an output, not as a not a file. We saw Flash. Flash is using a file. Flash don't put your results on your screen. Of course, you don't want to see millions of lines of next generation sequencing on your screen. But if you think about SemTools, we used SemTools for example, transforming the realignment results, which is usually a SEM file. When you aligning short reads to a genome, and you create a SEM file, then you use SemTools to create a BEM file. From the SEM file, a BEM file is the binary, much smaller version of the SEM file. In default, this BEM file is going to your screen. If you use SemTools, if you say, I think it's like SemTools, SemTools view or something like that, and then you have to, and probably you have to say -b to make a BEM file, and then you are giving the results.sem. If you say something like this and you have your SEM file, then it will be on your screen, the BEM file, which is not really what you want. So if you use SemTools like this, you will always do something. You will always redirect the output, and you just say results.bem. But why do you have to do this? Why it's not automatic? So the first reason is because you can name your file, of course. But the second thing is, and this is way much more important here, especially in bioinformatics, that you can very often give the output of a program to another program as an input. In this case, the very obvious example is when you create a BEM file, as you can see here actually. So we had here as this one here. I think we did, yeah, so, okay. So when you do a realignment and you have your SEM file, you have to convert to a BEM file, and then you have to sort it. and then you have to index it. So I have the output here. Probably this is a SEM file. Let me just check quickly. No, this is something completely different. This was a mesh output, but there was probably a SEM file somewhere here in this folder a long time ago. So there is a step when we creating a BEM file from the SEM file, and then we are indexing it. And this can be done in one step, just by saying that, okay, I am creating, so I say SEM tools. I'm not 100% sure that this is the whole command line. It's not important this time. The important thing is to understand how things are given from one program to the other. So I say SEM tools view -b results.sem if we have this file here, but we don't have. And instead of putting this into a file, I am just giving it to the SEM tools again. I think I can do this. I think I can do this with a sort. And then put this into the results.bam. Maybe this has to be done in the opposite order. So maybe you have to sort the SEM file first and then do the BEM file. I'm not 100% sure, but it's not important now. The important thing is that you are saving space with this, because you don't save the intermediate BEM file. You are creating a BEM file here, but instead of saving the BEM file on your hard drive, then opening it, sorting, and creating the sorted result BEM, it will be given by this program to this one, and the whole BEM file, which is somewhere between these two, is just existing in the memory of the computer. It won't occupy the whole, it will probably occupy quite a lot of memory. So be careful with this one. Don't try to pipe like whole genome sequencings, several gigs, if you don't have that much of memory. But in smaller files, usually some files are just a few hundred megabytes, so they can be put into the memory easily. And the BEM file will be in the memory, and it will be sorted, and only the final file will be written out. So you won't have so many intermediate files. You can use the pipe for this purpose. Okay, there is one more thing I would like to show you. So even if you don't really want to save all the outputs of your processes, but you would like to go back sometimes and look through what was happening, then there is a trick you can do. So in many Linux systems, in default, you have a command called screen with 2 E's. The screen will make you a sub-terminal. So you are using your terminal, which is using PuTTY or using the terminal app on your Mac. And this is one screen where you can communicate with the server if you log in. But by using screen, you are creating a sub-terminal. If I'm just press enter here, then there is a user license agreement, which you have to accept by pressing space. But then you see something very similar you had before. So it's like getting back your console, but it's actually not the same console you had. I can go to my home folder. Okay, so I'm in my home folder now. What do I have here? Okay, we have the test sh, so I can just show the content of the test.sh. okay? If I'm going out from this one by even saying logout, or by pressing the Control D, which I'm usually using to log out from terminal, then I will go back to the original terminal. And as you can see here, it was terminated. Okay, so it is not running anymore. If I'm saying screen again, I have to accept license agreement again, and I'm getting back a brand new terminal again. But let's do the same thing I did before. So I'm going to my own folder, and I am putting the contents of my test.sh script to the screen. And then I don't push the Control D, but I'm pushing the Control AD, Control A, sorry, Control A and D, no, Control A and no. Okay, finally I did it. So you have to push the Control A at the same time, but only once. Or first the Control, holding the Control, push the A, releasing both, and then D. So what was happening, if you are much more interested in how to use screen, there is a very good tutorial I can send you. But what's happening here, instead of, we get back our original terminal, but instead of seeing the screen is terminating, what we see is that we detached from this specific screen. I can now log out from the server. Okay, so I am now on my own laptop. I log back in. I go to the Scratch folder or anywhere. Okay, I will go somewhere else. I will go to Chioma's folder. Okay, it's absolutely no. So I can be anywhere, and I'm saying screen, but this time I'm saying screen -R, which means that I would like to continue what I did before. And I get back that terminal, that subterminal I used. Okay, as you saw me, I logged out from the computer itself, but it remained there. It is remaining there. It is running. So if you run anything here, and you are detaching, you are not logging out from this screen, then you can go back anytime, and you can see what is happening with your run, because everything will be there, will be saved. So if you have a flash run, for example, here, flash running here, you will always be able to go back and see what was in your subterminal. Again, I can just simply log out or detach by Control AD. I can go back with this one, or just Control D, and then it will completely terminate. So now I cannot go back with this one because there is no screen to resume. Okay, there is one practical usage of screen. If you are having kids and you want to set up a Minecraft server at home because they want to play together on a Minecraft server, then the Minecraft is usually running by using screen, because what is happening, you are installing a Linux on a computer, then you start Minecraft, start the Minecraft service, but you should start it within a screen a section. It has to run continuously. You can see what is happening. So if you are on the server, you will see that, okay, someone is now logged in and someone is building this, or they are communicating something. You can also apply different comments and make the weather different, for example. But you can always detach from the screen. The Minecraft server will continue running and your kids can play on it, but you can log out from the server. You can unplug the monitor and keyboard, and you can just leave the computer running to serve as a Minecraft server. It's very, very useful. Okay, so this is how you can use the screen. I don't know if we have Thomas here. No, he's not here. He is using something different on his HPC. I don't remember, but it's a different. So there are different types of these kind of sub terminals you can use. The screen is one of the most commonly used one. It is not always installed. So if you are working on a computer where you don't have screen, then you have to ask the system administrator to install the screen. There is one more thing I just want to say about the standard output and the standard error. And this is when you are working on a cluster PC. So there is a chance that many of you will use the HPC, university HPC, or any other cluster PCs. So as soon as you are working on a cluster, you don't really work on that computer you logged in. So if you think about our bioinformatics course server or the Hammond server or your own laptop, if you are using, I'm using the terminal here, I'm doing everything on this machine. Physically, I'm working on that machine. If you are working on a cluster PC, you usually log in to a login node, which is physically one computer, one machine, and you are submitting jobs, which will be executed somewhere else, completely physically somewhere else on a different machine. Which means that there is no chance that you can catch the screen. You know, it's not happening on that computer. As soon as you are using the normal way, and I won't speak about how to use HPC. If you want, we can speak about it, but actually there are very good tutorials, for example, at the university UIS. But if you want a short HPC course, I'm happy to do that. But if you work on the HPC, what you do, for example, if you want to run a bowtie, then the same bowtie command you use has to be put into a long file, which is also giving a lot of other parameters for the cluster PC. For example, you have to define how long your run will take, how much CPU cores you need, how much memory you need, what's your username, what is the account you are working on, because you may have to pay for running comments on the HPC. So all these things has to be in that file together with your real actual command. I want to bow tie these two files into that reference sequence. And then you are just submitting it. And then you wait. You wait for two things. If you run bow tie here on this computer, you just wait until the bow tie ends. On the HPC, you first wait until your job is given to a computational node, a production node, which means that for hours or sometimes for days, your submitted job is just waiting there and will not be started. And then you are, of course, waiting the same amount of time for the run. For example, I have a few runs, I think, at the moment on the HPC. You can see here, these are all, I went actually over my limit already. So these jobs here are already too much for the HPC. These ones which has the priority here, they are waiting. They are not started yet. And only these few jobs at the bottom of my jobs on the HPC have been started. And this is where you can see that, okay, this one is, for example, running for 43 minutes already. And it is running on the computer node, which is called CPU E749. That means that there are at least 750 computational nodes on the HPC, but probably way much more. So, so what do you do when you don't really have your standard output and standard error on the same computer you are working on? You can use the redirection we did. So you can give that kind of command which we did here with the abricate, that you are putting the standard output to file A and the standard error to file B. But luckily, when you define a submission script, and I will show you one just to show you how it looks like. CD RT. So on the HPC, you're usually able to define what you want to do with your standard output and standard error. 1 hour. Single CPU. This one is okay. So don't let me frightening you with all these lines. But if you look at, for example, here I define that I want this program running for 1 hour. I'm using this account, which is our HPC account. And here, well, I just wanted to show you that this is how the HPC is handling the standard error and standard output. So as you can see here, in the next few lines, this is just a comment line, but in the next few lines, I am redirecting the standard output with -O. It will go to the Slurm files folder, and it will take the run ID. It's not important, but it will look like hic pipe.log. And I'm also redirecting the standard error into another file. So in this case, I'm not using the more than or less than sign or other wizardry, but we have to use the sbatch own syntax. The sbatch is the program you use to submit programs to the HPC. So it's a bit different, but it's again very important to know that if you want to keep your error logs, if you want to keep your outputs, then it's better to put them into files. In my case, for example, many of you know that I built up the pipeline for HiC metagenomics. It consists of at least like 20, 25 different steps. And in these steps, I have, for example, the flash. In that one, I have the Clumpify we used. I have the spades. And when I developed the whole pipeline, I also wanted to have a kind of summary on each sample at the end. So I wanted to know that, okay, this sample started from these 2 files. I had a number X of short read sequencings. Then I filtered out that percentage of duplication. I merged that percentage by flash, and then I built up hundreds of thousands of contigs. So all of these numbers, and when I created this final summary script, 80% or 90% of the information I put together in this one came from these log files. So again, these are not my results. This is not my last table at the end, which is about, you know, what kind of bacterial species I have and what kind of antimicrobial resistance genes I have inside them. It's only about the sample and technical information. But it's important because if you see something weird, something wrong, then this is the first thing you go back. Is there something wrong with the sample? Is there something wrong with the sequencing? Did I lose too much reads during the data application? Was there any unusual thing? And instead of going through 20 or 25 different log files, I created one script once, which extracts all these informations. I think I can show you one of these. It is somewhere here. Project, full project reports. This is it. This is the folder. Oh, I only have a few here at the moment because all the other ones are compressed. But if you look at this one, this is not extremely extensive. Yeah, I don't have too many things here. Probably there was some missing files here, but there should be a lot of lines here, which I cannot show you now because it's not here, sadly. Yeah, they are all just very small. But again, just have to know where are your log files and how to look into them. And this is actually the last thing I would like to tell you today. What are those main programs you may use to actually to see what is in these outputs? The reason why we do this, because sometimes you don't really want to go through the whole file, especially if you just analyzed 600 different sequences. You don't really want to go through thousands of lines of logs and see what is what has happened. So if you go back to the example of the abricate, and I did this to check if Chioma did everything perfectly, and actually she did everything perfectly, but I just did some checks on the abricate run. So what happened here, we have a lot of FOSTA files, hundreds, and she wanted to do the abricate on all of these files and see if it what are the antimicrobial resistance genes in these files. And as you can see, I did the error log here as well. I actually did it with the minus debug, I think. So if you say abricate again, I think I used the minus debug as well. So it is even more verbose than it's usually. So if you look into the error log, it is a lot of lines with a lot of blast comments here, and here we have some Perl outputs. These are variables actually printed out. So it's a huge amount of data. If we look at the how many lines we have in this log file, then it's 40,000, 41,000 lines. You don't want to go through this file manually. But maybe you want to know how many of these 600 were analyzed, okay? So let's just take a small look into the file again. So every time a file is processed, then abricate says that I am processing blah, 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 blah. Next time I am processing blah, 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 blah. So if you would be able to count how many of these lines you have, then you would be able to tell how many of these 600 something were analyzed. Okay, so the next thing is that how can you do this? The simple thing is just have this word processing. The processing word is only there in these lines. There is no other processing. It's only there if it says that I am processing this file. So the easiest way is that we are grepping, and again, this is something you already saw before, I think, in the error log. So this means that it will print out all the lines which contains the word processing. Maybe you are going for a word which is not that unique. Maybe the processing word is somewhere else in the middle of the sentence, somewhere else. Then you can use this sign. This means that I only want to see those lines where the processing word is in the beginning of the line. This means that it's in the beginning of the line. Of course, we will get the same thing. Very important thing that as everything else in the Linux world, grep is also case sensitive. So if I'm doing this, then no line will be printed out because it is always starting with a capital P. But you can ask grep to be case insensitive by saying -i, and then you will get back these. Of course, this is again not something what you want to count by your hand, 1, 2, 3, 4, 5. No, it's not working like that. Let's go back to our original one. But again, this is going to the standard output, and I can just simply pipe the standard output, give it to WC -L, which will count me how many lines I have, okay? So as you can see, 689 of these FOSTA files were analyzed. Do we have this amount of file here? If I'm saying ls, the problem is that I also have a few other files, but if I'm saying ls *.fosta, then I only have the FOSTA files here. Okay, and if I'm saying this and I'm piping the standard output to WC -L, then you can see that it's the same number, 689. I'm going back here, 689. So we have 689 files here. All of them were analyzed. If you want to see how many of these are lacking any antimicrobial resistance genes, because that was actually one of the reasons why we had to rerun every kit, because it was a bit weird. And you will see soon why I'm saying this. Less error log. So as you can see, if the every kit also reports how many genes it found. So okay, if you say found blah 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 genes, again, if you just looking for found, and we have the same kind of, oh, now we have a bit more. That's interesting. For some reason, we have a few other lines here. Okay, the reason why we have, because there is also a few other reports in the beginning of the log. So what we can do is we can pipe this to another grep. What I want to do, I want to print out all the lines which are starting with found, but also having the word genes in it, because I don't want to print out any of these. There is no genes in these ones. Or I can just look for the, now the FOSTA is not good because we have the FOSTA word here. So we cannot go for the FOSTA, we can go for the genes, okay? So I am giving the standard output of the first grep to the standard input for the second grep. And this time I don't give a file name, but I'm grepping, I'm filtering the standard output of this one. And if I'm now using the WC -L, then we will have the correct number of genes or FOSTA files. But this is not, this is only telling us that, which we already saw that 689 were processed. but we want to count how many zeros we have here, okay? So 1, 2, 3, 4, again, this is not the way how we should do that. There are many different ways how you can do that. So again, we are having this output, and we would like to see how many of these lines having a 0. We cannot really grab to zeros. This may work. The problem is that you have many zeros here as well. You know, you can have zeros in the file name. You can have 10 genes, which is 1 0, and it will be here as well. So in these cases, it was okay. But in this case, for example, it's not okay. It's not an output where no AMR genes were found. There was 1, but there was not a 0. Okay, so this is not working. Maybe you can try something like this. So you want to grab for those lines where you have a space and a 0 and a space. This should work, and this is actually working, but it's not the nicest way of doing this, I have to say. So, which is much more elegant, is that we cut out this second field. As you can see, if you go back up here, there are always spaces, you know, because this is a sentence. Found, space, number, space, genes. Okay, so if we use the space to separate the words, and we only extract the second one, then we can actually find or print out just the numbers. And for this, we usually use the cut command. Again, these are all built in Linux command. Cut, grep, WC, they are always there for all Linux or Unix-based systems on Mac as well. Cut is using spaces, I think, in default, but I'm not sure. We have to check it later. But we only have to sit. I want to cut out the second field, -F for field, cut -F2. I want to cut out the second field from the line. It's not working because probably cut is using tabulator. Let's see, non-cut. So if you go, yeah. So if you look at this here, it says that you can give with -D, you can give the delimiter because cut is using tab, the tabulator, as the default delimiter, which is usually the default. You know, if you have a TSV file, tab separated values file, then you are using tab. But in this case, we only have a space. So instead of using the tab, here we have to say -D. So we are defining the delimiter. If you have a comma separated value table, then you can say this. So you are using the comma, or if you are using semicolons, you can do this, and then it will be separated by using semicolons. But here we are only using the space, which is just putting a space between two quotation marks. And then we got back the numbers. This is not perfect yet, because again, we have here almost 700 numbers, and we don't want to count how many zeros we have. But we have all the numbers here, not just the zeros. The good thing is that with the same single command, we can count how many zeros we have, how many ones we have, how many twos we have, and so on. So first thing, again, as you see, I am just passing the standard output. So this standard output from here goes to here, and then it goes, this standard output goes to here. And now I will put it into a new program called sort, which will sort numbers. Sort is doing alphabetical sorting in default. So again, if you have 10 and 11, then it will be before 2. So instead of using alphabetical sorting, we are using a numerical, and this is done by -g. So if I'm just pushing this, then you can see, okay, we don't have anything with more than 10, but we should have had, yeah. But as you can see, the last one is 9, and then all the 8s, and then all the 7s and 6s, and 1s and 0s. So it's already sorted. And now we can use the final command, which is unique. If you just use unique, then everything which is the same in the next line will be merged. So instead of having hundreds of zeros, we have 1. Instead of having, I don't know how many ones, we only have 1. So we lost all the numbers here, but luckily there is an option for unique that together with merging all the lines that are having exactly the same thing as the previous line had, it's not just doing this, but also counting how many of that was merged. So you can just use this -c. And then, voila, you can see that you have 353 FOSTA files with absolutely no AMR genes, 49 with 1, 5 with 2 genes, 6 with 3, 6 with 4, and so on. So you can easily see how many AMR genes you have in your files. So this one line actually almost having all your required comments you can use and you will use to find the important information. You can multiply these. You can first cut 2 or 3 fields. You can always do this with multiple fields. So if you want to cut from 1 to 3, then just you can say that I would like to cut the first 3 fields. And then you will see that this was cut out. So the found 0 genes, found 1 genes. Okay, so the first 3 words instead of just the second word, the first, the second, and the third was cut. But if you say 1,3, then the first and the third will be cut, which is found and genes. And of course, because you have all found and genes in every of these lines, it will be just merged into one. You can count how many of them was merged. Sometimes you don't have something you can use to filter forward. So if you remember, we used the found as our first grep command, but as you remember, we had a few lines we didn't want to include in the very beginning. These ones, we don't want to count them. Let's just say that we don't have any words here. We don't have the genes word here, and we don't have any other things in these lines that we can use to further filter. Then what we can do is that we can use something that we have here, but not here. And for example, if you look at this, we have this arrow looking thing here. So what I can do if I'm grepping to that, I hope I can do this. Yes, I can do. Then I would just filter out those lines. But of course, I don't want to filter out those lines. I want to throw away these lines and keep all the other ones. This can be done as well with the same grep command, but you only have to say -v. So with -v, you are letting through every line which is not containing this. So this is a kind of opposite. So if I'm doing this, I will get back all the lines with the important information for us. And in the beginning, there is nothing here. Okay, so this is what you can use also. I'm pretty sure that if you start doing these text-based works many times, it's just simply enough just to use the grep and cut, and the combination of these grep, cut, WC, and if you really want to go up a level, then the next thing you should learn is oak. I won't go into details because oak is actually a programming, almost like a programming language, but just let me show you one nice example here. So if we go up here, so we have all these lines, and I'm asking oak to print me out all the lines where the second field is equals to 0. You know, this was what we wanted before. See all those lines where we didn't find any genes. Then it's here. It's so simple. But again, oak is quite complicated, but it's a very, very, very powerful tool actually. So if you really think about doing a lot of command line magic, then maybe it is worth to look after. If you want, I can help to find something, a good tutorial about oak. In longer term, it is really worth to learn a few tricks. And there is only one thing I wanted to show you. So if we look at the abricate output, for example, we can look at this one, but we can also look at the one which we made before. No, we have to look at this one, which we have here. So we have an output here. This is an abricate output. In many cases, you have a tabular output from programs. If you do BLAST, if you do abricate, usually you have a tabulator separated table. The problem is that, you know, you have the header here where you have a small word, a short word, and a tab, and a short word and a tab. So you are already defining the third column here, but in your data and at the same position, you are just having your file name. So it's not extremely hard to identify what is the sequence because it's always the second one. But if you want to identify what is the accession or what is the percentage of identity, then you have to go through and count all the fields, which is a bit of, you know, I mean, it's not extremely efficient. Of course, you can download this file and put it into Excel, and then you will just ask Excel to separate the fields by using the tab. But what if you want to see, just quickly look at this on your own computer? And there is a command for this, of course, which is called column. In default, let's just look at the first 10 lines. It doesn't make any difference, but if you say -t, so if you want to see a table, then it will be a bit better, but it's not good yet. And I will, oh yeah, it's good. It's actually good. The problem is only that we have I cannot see it because it's too wide. So let me just now reduce my character size just for this very short time, and I will give it back to you in big one. Even this one is not enough. But as you can see now, all the headers are above the good column. So the sequence is above the sequence, the start is above the start, the end is above the end, and everything else is above the good line. But even here, we have one more column which is not here. So this actually is too wide. the whole table is too wide for my screen at the moment. But if you have a bit smaller table, then this can be very useful. And I think this is what I wanted to tell you today. We spoke about, there is one more thing I wanted to tell. We spoke about putting things into the background before, you know, when we run a command, even this one, and you just put this at the end, and this will run in the background, which is very useful if you are running something very long. There are different ways to do this. One way is, for example, opening a new terminal, subterminal with screen, and do everything inside that one. And if you just detach with the Control AD, then it will run. It won't run in the background. It will run inside that terminal. But you can log out if you want, because that screen will continue running. So that's another way to run something continuously while you logged out. But you can also use together with this sign. So if I'm having a flash 1.fq and 2.fq, and if you run this in the background, then you can say in the very beginning no hub. If you say no hub, then in many Linux machines, it will ensure that it won't stop when you log out. Sometimes if you just do it without no hub and you log out, then it will stop running in the background. It depends on your shell. I just found this out today. Let me show you. Where is that? Command line, trust and tracing. I think it was here. No, it wasn't here. Yeah, it's here. So, yeah, and this one. So if you are on your terminal, maybe this is not extremely important, only if you have your own server and you realize that if you put something in the background and you log out and it stops running, then maybe this is the problem. Maybe this parameter is not set well. So if you, what do I do? If you run this shopt and pipe it to grep and grep for hop-on, then this gives you, if this is on, that means that if you log out, then everything you run will be terminated. Even if it's in the background, it will be terminated. If this is off, like it is for us on this server, then if you put something in the background and then you log out, then it will continue running. No hub is not the same as BG. No hub is not, I didn't use no hub for a very long time, and no hub is not the same. So according to this, even if you use no hub, you have to put it in the background. So the perfect use for no hub is like this. So no hub, then your process, and then put it in the background. The only thing what you can win with no hub, first of all, if the Linux machine is configured to turn off or terminate your runs when you log out, then with no hub it will not. In our case, that's not a problem, because without no hub, if you put it in the background, it will remain there. It will continue running if you log out. But the other thing that no hub is in default putting the standard output and standard error into a file. I think it will put all the things into the same file. I also found it somewhere here. Yes, it is here. So NoHub, on the other hand, redirect the standard output and the standard error to NoHub out. So where you are, where you run your script, you will have all the standard error and standard output in a file, saved into a file. But you can also do this by those tricks I showed you. And Chioma, for your question before, my answer is yes, of course. So yeah, you can use NoHub if you want. I have never used it in my life, and I was very happy without it. But you can use the most important thing is when you put something in the background, try to log out quickly, log back in, and check if it's running or not. And if it's not running, then there is something wrong with putting things in the background and letting them run. And if it's not running, then you have to think about using NoHub, for example, or using Screen. NoHub is not using any extra resources, not using memory. Screen is using some, but Screen has a lot of other functions as well. So it is actually a very good and multifunctional tool on the Linux. Screen is maybe not installed on the Linux machine. NoHub is always there. It is part of the main Linux distribution. Oh, okay, right. I think that's enough for today. How to use the NCBI gap? Is it a program? I don't think I have met with that yet. Let me just write this up, and I will look for these things for the next time. Okay.
Okay. Thank you.
Also, if you have any other questions like this, any other problems, just please email me, and we can now start discussing your problems. Rhiannon, I will go back to your emails as well, and I will think about doing something with your data. Also, we will have to start processing Alex's data as well. He wrote an email to me that he is waiting for the results, so I will do it together with you. So I think we will do some problem solvings from the next time and real world examples again. Any questions for standard error, standard output, grep, cut, WC, logs, grep? I think grep was again. If there is no question, I think we can stop here.
Hello?
Hmm?
Hello, can you hear me? Sorry, I was talking into the monitor and not the laptop, and the monitor doesn't have a microphone, sorry.
I can hear you now.
Sorry, I was just going to ask, and it's probably a really stupid question, but it was on the grep bit. So for example, the found, and then you wanted genes and you wanted no genes, basically. Is there a reason why you couldn't put found naught genes in inverted commas and do it all at one go? Is there a reason you can't do that?
Yes, it is working. It would work, yes. But I think it's, yeah, I showed you that you can even put there like spaces, all space.
Yeah.
But it's not a good habit to use space anywhere in a Linux system. So the problem is that what you see as a space sometimes is not a space. Sometimes it's something else. It's a tab or so. so that is, or more than one species. So that is why usually it's not a good thing to
Okay, yes, too
to
risky.
include species in your searches. It is working many times, but I would much more go for
No, I think
words or for something, you know.
Okay, I
Yeah,
understand.
the one of the best example is the FOSTA file. You know, in FOSTA file you can always use that FOSTA ID at the beginning of the line to for example print out or grep for just the ID lines and not grepping the sequence. Or if you want to just you know, count how many nucleotides you have without the FOSTA headers, then you can just use grep -v and use the more than sign as the identifier of the FOSTA header line.
Yeah.
So it's usually much better, and you always have to be very careful. I don't know if you remember when we spoke about. Let me just quickly show you this. If you look into a FOSQ file, do we have a non-zipped? No. Let me just quickly unzip this one. So if you just look at the first 10 lines of a FOSQ file, then you know the FOSQ is one record in FOSQ file is always 4 lines. You may remember this one. The first line is the identification of the sequencing machine and the position of that particular dot. The second line is always the sequence. The third line is reserved for comments. It is almost empty here. And the fourth line is the quality string. And if you are looking for the ID line, you can see that it's always starting with this @ sign, always each ID line. But you have to be very careful because you cannot grep for this. You cannot even grep for, you cannot even say that I want all the lines where I have this sign as the first character in the beginning of the line, because there is a chance that one of the quality strings here will have an @ it. I, of course, probably I won't see any now, but it is possible to have it in, it is within the range of the quality scores. So you have to be very careful. That's the take-home message from this one. You cannot use colon because colon can be there as well. I think in the FOSQ files you cannot use grep actually to find out how many ID lines you have, or you cannot easily grep the sequence out. You can have AC and G. You cannot have G. You can have AC in your quality line. So probably you may be able to grep for T, but who knows if you have a T in your sequence. Maybe you don't have a T in your sequence, and you can also have T actually. I think in the ID line. So FOSQ file, for example, is not ready for grep. And when I'm processing FOSQ files, I am processing it by the position. So I'm counting, and I know that okay, I started with line 1, line 2, line 3, line 4. Then I reset the counter, line 1, line 2, line 3, line 4. So in that case, I'm processing the file by position, not by string. So please don't use space. Don't use space in file names. Don't use space in searches.
Makes sense.